Alright, so I really don't feel like graphing this, but I suppose we will. Cosecant bounces off of a sine graph, right? Because it's the reciprocal of sine. So if I draw the sine, everywhere where the sine is 0, my cosecant has an asymptote because 1 over 0 blows up. And the cosecant just bounces off of that thing, these little guys here and here and there. So if and of course, they don't have just a normal y equals cosecant x, as if this graph weren't bad enough. They've got it reversed. So instead of having my asymptotes at x equals 0 and x equals pi halves, I have my asymptotes at y equals 0 and y is pi halves. And instead of having this point be, oops, that should be pi, my bad. No. This is sine 0 at pi, sorry, pi, and then this point here is pi halves. So instead of having the point pi halves and 1, I will have the point 1 and pi halves. And my guy is going to go as x goes, y gets really, really big when x gets really, really small. So x is going to get big, really, really big. So it's going to go this way. Yes, yes. Alright, so that's the chunk that I need. And I need to go from pi fourths to 3 pi fourths. So I want, and then I've got this x equals 0. This chunky region revolved, of course, around the y-axis. Alright, fine. Picture done. So, we're going around the y-axis, so we want to make sure our function is prepared, should be x equals, which is good. Then we want to start drawing those radii. So if we start at the axis of rotation and draw out until we hit something, that's a radii. Could we go any farther? No, there's nothing else out there. So we just have one radii, just an outer radius. We don't need to worry about the inner radius, it's just 0. So it's a disk, not a washer, I suppose. There's no hole in here. So all we gotta do is say that our volume is the integral of pi times the integral of our radius, which is just our function squared, dy. And so since this is in terms of y, our limits are in terms of y from pi fourths to 3 pi fourths. And now that's our setup. All we gotta do is solve. So we know that the derivative of cosecant squared is cotangent, negative cotangent. So fortunately that was rigged for us, and all we have to do is evaluate it from pi fourths to 3 pi fourths. And so if I pull the negative through, I'll have negative pi, and the cotangent of 3 pi fourths is -1, and then subtract when you plug in the pi fourths. The cotangent of pi fourths is 1. So we have negative pi times a negative 2, so hopefully we get 2 pi. Let's check. Huh, yes, they agree. Awesome.